Finally, the holidays book right after the fabulous Checkmk Conference 10. No more rental stuff this year. I'm gonna splurge on some serious surfing equipment. This website looks to have everything I need. Let's grab this. A wetsuit. Can definitely also use it in Munich to go to work in June, duh. Of course, I cannot go without a kite, and safety first. Definitely getting a helmet. The prices look good. Let's check out before I change my mind. Huh? What's that? How am I supposed to stay committed to impulsive purchases when they are impossible to make? It's simply not worth it. I'd rather go to the Alps.
Tja, what happened here?
Hey, finally.
What happened here? Two things in general. One visible, we had a bug in the tax calculation module and the price calculation was broken. The invisible thing is, what happened? We have an annoyed customer and perhaps a bad review about the shop. And the customer perhaps buys from a competitor and in the end we have a revenue loss. Imagine this is your company. How would your monitoring look like? You would set up a basic monitoring for your operating system, no problem. You would set up some service checks. Not in sync, okay. Some service checks for TCP port 80 or to check if the Apache server is running. And also implement some checks which check the homepage or the validity of the certificate. Everything is green. But the only one who knows from this error is your customer at the moment. So everyone who runs IT is on a kind of higher mission. If you run this web shop, then you have to make sure that customers can really use this system, that they can buy articles from the web shop, and that the system in the end generates money. And for that reason, you must not only monitor from your perspective, but also from the perspective of the customer. Because your internal monitoring won't tell you in full detail if the full stack of this web shop is working or not. So what means working? This is measured in 3 dimensions. First, availability. So do these services respond at all? Performance. How is the response quality? How fast do these services respond? And in the end, functionality. And functionality is something you can only hardly monitor with Checkmk because there is no standardization for web shops. There is no standard check for that. And for that reason, you need to automate this process. You need automated tests. This is such an automated test which exactly does the same. It exactly does what a real user would do on this web shop, again and again and again. And if something goes wrong, you get notified from your monitoring system. And if this test fails, this check, then you know probably your customer has the same problem. You also need detailed log files which help you to tackle down to the root cause of this error and which give you a nice error message which clearly communicates what's really wrong with your web shop. For example, the expected price wasn't found on this page. So this is synthetic monitoring in a nutshell. And this adds a huge added value to your monitoring system, and the possibilities here are really endless. We at Checkmk are on a mission to make this integration into Checkmk as seamless as possible. And this is done in 3 different dimensions. First, develop the test, then you have to run the test somewhere, and in the end, you want to monitor the results. Let's talk first about the development. which also raises the question, which is the right tool for that? And what are the requirements? A testing tool should be easy to use, accessible for non-programmers in the best way, low code, that everyone can use it. It should kind of match this sweet spot between user friendliness and flexibility. It should also be able to test anything. It should be technology open and not be focused on one single technology. And it should be future-proof. You certainly do not want to be dependent on some software vendor and their strategies. There are a lot of different technologies to write functional testings, and the main domains for sure are web testing and desktop-based testing. You can do this with Selenium, Playwright, PyAutoGUI in different languages. There are a lot of different programming interfaces for these technologies. And in this example, you see Python code which uses the Python Selenium package. This example shows the same test. It's always this test for this web shop in Playwright. This is JavaScript. This shows the usage of PyAutoGUI, a package for Python, which makes it possible to automate desktops, mouse and keyboard actions. This works, but who can write this? Who can read this? So whenever you are fixing yourself on a certain technology, you are risking to run down a rabbit hole, because each of these tools have different dependencies, requirements, peculiarities, are not compatible to each other. But you can use these technologies on a higher level. You probably know Ansible, for sure. And just like Ansible perfectly abstracts different tasks on different operating systems, so does Robot Framework with its own language and its own libraries on a higher level. I discovered Robot Framework in 2019, and for me it was the perfect fit to bring end-to-end monitoring or synthetic monitoring into Checkmk. And this is where I started to write RobotMk. And short after that, Checkmk also evaluated and explored the possibilities. And they had the same questions in mind. What is the right tool we should choose for this challenge? It should be a solution which customers can rely on, which does not pose any risk to customers, and so on. And how flexible is this solution? And when we're talking about flexibility, then it's really important to mention that the Robot Framework ecosystem offers libraries for every technology you can imagine, which can be automated with Python. If there is a Python package, you can go very sure that there is also a library for Robot Framework. And all of them are open source and can be used in mixed operation. In the talk before, we had heard about parsing and validating JSON and XML. It's no problem. There's an XML library, there's a JSON library. Yeah. I have written tests which do exactly this, downloading some JSON and XML data and validate them and so on. And if you have a special use case, you can always write your own library or supplemental keywords for existing libraries in Python. In Robot Framework, this web shop test looks like that. It's clear, it's understandable, and maintainable. And when you're writing Robot Framework code, you do not have to think about, okay, my test is ready. How do I now write out a comprehensible log file? If you are using Robot Framework keywords, which can have arbitrary names, the log files itself produce a meaningful log file. And this is very helpful. Another important consideration was how future-proof is such a solution. Robot Framework is open source since over 15 years now, and it has a great community. This year when I was in Helsinki at the RoboCon conference, they cracked the 20,000 users mark on Slack. So this is quite impressive. So if you have a question about Robot Framework or the different libraries, chances that you are getting an answer from some of these Slack users are very high in a very short time. And even for Robot Framework, chances are high that Pekka Klerk, the founder of Robot Framework, answers himself. He's a very nice guy. You can meet him in person at the conference. So the Slack channel is your first address to get support. And this makes a big difference, for example, for commercial solutions, which are expensive, where only a small amount of people understand the tool and can give you support, and not for free. Another outstanding thing about Robot Framework is the Robot Framework Foundation. The foundation is a non-profit organization with over 60 companies now as a member. Checkmk is a member. My own company, Elabit, is a member. And all these companies support with their annual membership fee, which is always based on the number of people which use Robot Framework, support the project and protect Robot Framework against any takeover from a foreign company. And this happens because the foundation pays the main developers of Robot Framework. This is why Robot Framework is developed so fast. There are always new releases, bug fixes, and so on. So this is really outstanding. And in the end, this ensures the sustainability of this project. The foundation also sponsors the big conference in Helsinki, meetups, or if you have a great idea about a new library you want to write, but you need some days for that, 5 or 10 days, you can apply at the foundation for a small sponsorship. So they can pay you to do the first POC, and so this supports that the community can give something back to the system. So in these 3 categories, Robot Framework is, at least in our opinion, a clear winner. And I would like to back up this in a few examples. Have you ever tried to automate a Citrix session? You would first have to set up a web session, log in into the Citrix portal, then click the right session, and then the session opens, and then what follows is not any HTML content anymore. Yeah? So in that case, after you have established the web session with Playwright or Selenium or something, you can just change to another keyword library, which is in that case Image Horizon library, which simply does image recognition on some parts of the screen. The library doesn't know that it's operating on Citrix. And yeah, these keywords can be used in mixed mode. So this is very flexible, and I do not know of any other tool which does it in that kind. This example shows you how it's possible to... Does it play? Yeah. This does a login on a sample login page with a 2-factor authentication code, which is calculated on a minute basis. And I would say with a pure web testing tool, this is not possible. With the Robot Framework, it's kind of ridiculous because there is a library for this TOTP calculation, but it has only 8 lines. So if you see this TOTP PY, these lines are written by myself. So this is only one simple function which takes your personal password and it returns back the 6-digit token. Very small and tiny, but very helpful to do scenarios like this. This is an example of GeoBasis Brandenburg. Thanks to Carsten Schöke for letting me show this. This is a map application, and one concept is they are gaining data from different map providers, and if some of these providers has a problem, then they are showing in the PDF document, which prints the map into a document with a red layer. Their reason is, before they show any wrong data, they are showing nothing. And a red map is always an indication for wrong data. And I've written this test to check that there is always valid data. At first, you see the test running with Playwright, and then it clicks the print function, the PDF gets downloaded, and then I'm switching the library. I'm using the doctest library, which is able to compare images in PDFs. Also subsections of PDFs. It's very cool. And in that case, the test is successful if there is no match. If we do not see the red area in the downloaded PDF, everything is okay. If we see the red area, if there is a match, we have an error. And the code of this looks like that. You see the keywords. These are all user keywords. So this is not the complete test, for sure. Yeah. So there are many resources imported. But this is what makes Robot Framework so flexible, that you can outsource certain keywords for a certain application, module or something in resource files, and reuse them again and again. So with Robot Framework, the easy things are easy and the complex ones are possible. This completes the implementation part, and we have seen that Robot Framework is an excellent tool for that. Let's move on to the execution of these tests. I want to explain what's happening here. For sure, tests which open browsers and applications and so on cannot happen on the Checkmk server. You do not want to add additional load on the monitoring system from these tests. So they have to happen on a dedicated machine, especially if you want to test applications on a desktop, for example. This is the most common reason for a dedicated machine. Robot Framework and its libraries need Python installed. You have to install all these dependencies. Some of these libraries depend on Node.js, like the Playwright library. This has also to be done, and at least you have to take care about the scheduling. And in the end, this can everything become very complex because the Checkmk agent is not really designed for this kind of execution. In 2019, I started to think about this, where I started to write RobotMK, and this got great perception by the community, and since 2022, I'm working now partially for Checkmk to integrate RobotMK into Checkmk under synthetic monitoring. So let's have a look on the architecture, how we try to automate as much as possible. So everything you see here in the purple frame is configured and deployed by the bakery. The MSI installer for this Windows machine brings the Checkmk agent, of course, the RobotMK scheduler, which is very new. This is not a plugin anymore. This is an executable written in Rust completely, which is running permanently side by side to the Checkmk agent. There is also a scheduler config, which is produced by the agent bakery. And we are also delivering a small binary called RCC. And with the help of this tiny but very powerful open source tool, we are able to create these Python environments under the hood individually for each single test suite. This is something you had to do previously on your own with one environment per machine. With the help of RCC, you can create as many environments under the hood as you need. And in the end, the RobotMK scheduler then can execute the individual suites in their isolated environments. Everything is under the hood. So on a virtual host, everything you have to do is to install the Checkmk agent to get this running. Almost in version 2.3, we have one little piece missing, and this is the placement of the Robot Framework files. So in 2.3, you still have to copy the files or clone them from an internal repository or something. This is what we are targeting in 2.4, when we are talking about managed robots. More on that later. If you know RobotMK version 1, you probably know the bakery rule. Who uses RobotMK version 1? Can I see some hands? Who is using RobotMK version 1? Okay. Then you probably know, thanks, the bakery rule. And the bakery rule only got minimal changes on the surface. We added some feature on top of that. You know that RobotMK version 1 was only able to execute the suites sequentially. And on top of that, we added a feature called parallel plan groups, marked in purple here. And with that, we are forming groups of sequential executions. So in fact, the RobotMK scheduler doesn't execute the suites anymore. It executes the execution groups. These are the ones which have an individual execution interval, and these groups can be executed also in parallel. So by using that, you get the best of both worlds. You can use parallel execution, but if needed, also serial execution, which is very important if you, for example, want to run tests on a Windows desktop, because the desktop is a resource which should only be used by one test at once. In that case, you need a sequential execution. The single execution is what we are now calling a plan. In version 1, this was called a suite, but that's not correct. A suite is what Robot Framework is executing. And this, all together with all the parameters you see here, is what we are calling a plan, together with all this Checkmk stuff here. Then we have the Robot Framework parameters. With these parameters, you have the full control over the execution of Robot Framework. You see, for example, the variables. I'm passing from Checkmk all these variables for this article, which should be searched by Robot Framework in the web shop. No need to fiddle around in config files or in the Robot Framework code itself. You can pass all this data from Checkmk to the target host. Normally, the RobotMK scheduler runs under the same context as the Checkmk agent, and so do all these Robot Framework tests also run in the local system context. It's also possible, and if they are running in the system context, web tests can run completely headless. But if you have the need for a desktop-based test for some installed application, it's possible to specify a user which then needs a logged-in session. This is what we address in one of the next versions. More on that later. Okay, let's talk about monitoring. This is where the rubber meets the road. We see that it's important to have a high-level overview about your complete synthetic monitoring landscape. And in 2.3, we have integrated a dashboard which shows you all these important informations at a glance. You see the number of test nodes, number of OK tests, top test runtimes, and so on. We also added a table-like view for all your tests. It's possible to group all these test services by application name or by variant. A variant is just a variant of an execution in, for example, in a different language or for a different environment, production, test, integration, and so on. And by the way, when you are talking about tests, we are talking about the services. In version 1, it was possible to discover tests, but also suites, which are collections of tests. It was also possible to discover single keywords. In version 2, we decided to stick to the test concept. So RobotMK discovers the test. And this has a reason, because tests in the terms of Robot Framework have a special meaning. It's all about the tests. And test is what you can see here, because this is the central point where you put all your test logic into. It's also possible to generate custom graphs of all your runtimes, so keyword runtimes inside of a test, and so on. And as shown before, the integrated HTML log file viewer shows you quickly the root cause of an error the HTML log file is transferred automatically together with the agent output to the Checkmk server. And yeah, again, in the web shop example, you quickly see with integrated screenshots, base 64 encoded, what the real reason was, and yeah, meaningful error messages. And since we are on a monitoring system, the topic of monitoring shouldn't be missing. It's possible, like in version 1, to monitor the runtimes of different keywords, but it's also a kind of convenience function to automatically generate graphs for all these high-level keywords. Depending on the kind of how you are writing your robot framework tests, you can create high-level keywords which do not have any contact with the implementation. So they are clearly describing open web shop, add item to basket, and these are the keywords which you have on the highest level, just below the test level. And with that option, you can create automatically graphs for all these high-level keywords. Okay, so this is synthetic monitoring in a brief introduction in Checkmk 2.3. And this is only the beginning. Version 2.3 kind of paves the way for all these other things we have in front of us. We have a lot of ideas in mind, and we want to improve these three areas: develop, run, and monitor. And this slide should give you an idea of what we are targeting. First of all, we want to make your development experience more easier and smoother. We are currently evaluating to create an own extension for Visual Studio Code, which then could be connected to Checkmk, for example, to download templates. So what do you want to do? A web test, okay, download the template, and you get the complete configuration files for RCC, a nice skeleton, for example, in the robot framework test, some documentation. All that is thinkable. And in the end, if you have written your robot framework test, you can upload the robot back to Checkmk. And this leads to another topic, the managed robots. I've mentioned that you are currently responsible to place these robot directories on the target machine. And this fills the gap. The managed robots are the robot framework tests which are managed inside of Checkmk. And in the bakery rule, instead of specifying all these different parameters, you can just select which robot you want to deploy on a specific target host and override specific settings, of course. We also want to support Linux as an execution system, which is the minority of operating systems where synthetic monitoring tests are run, but still a valid point. We also want to make it possible to run Windows desktop-based tests in headless RDP sessions. This is crucial for environments where security is very important. It's always important, of course, but as mentioned before, currently we are relying on an unlocked session with one single user, and with that feature, we are able to run the test on a locked Windows machine, and under the hood, we have headless RDP sessions where the tests can run. And then we want to make it possible to run robots in a Checkmk cloud with a special agent. So the special agent just triggers container starts in the cloud so that you can monitor your service from different locations all over the world, which doesn't need any test nodes from your side, of course. And we attached great importance to even better evaluate and utilize the data we are getting from Robot Framework. In detail, this means we want to support custom metadata of Robot Framework. It should be possible to also scrape data out from applications and to use them as metrics in Checkmk. So imagine you have some old legacy application without any API. You do not have access to the database, so a black box system. You could write an application test which clicks through the application, and with OCR, which is possible with Robot Framework, you can extract certain areas where important KPIs are, which are then exported to Checkmk as a metric. And you can monitor these against warning and critical thresholds. And connected with that, these keywords which are important are called KPI metrics. We want to make it possible to make these keywords discoverable, to get more insights, more status, and more data. So we have achieved a lot, and we have still, as you see, a lot of things in front of us. And I would like to take this opportunity to thank my developer team, Jörg, Solomon, and Luca. It's a pleasure to work with you, and I'm curious about the future. If you want to test synthetic monitoring, then I highly encourage you just to try it out, because if you are using Checkmk 2.3, you do not need to install anything. RobotMK or synthetic monitoring is already included in Checkmk. There are up to 3 test services for free. And just try it out. If you want to learn how to integrate these tests, to write these tests, there are different resources. There is, at first, the official documentation of synthetic monitoring inside the Checkmk documentation. On the Checkmk YouTube channel, there are already 2 videos about the topic, the Checkmk blog, and the last 2 topics are projects of mine, the RobotMK homepage, where I publish news about Robot Framework and the ecosystem, as well as deep dive articles about the technology and nuts and bolts. And lastly, if you want to learn how to write these web-based tests, for example, how to use this image recognition and so on, I'm planning to release an online course since 3.5 years now, but now it's almost ready, and the closed beta will be released within the next weeks. So if you're interested, then sign up on robotmk.org/academy. With that, I'm at the end of my presentation, and I'm happy to hear your questions. Thanks.
Okay, we have obviously a big question. How is it going to be licensed? And maybe I take that one. So what we license are the tests. And now that obviously begs the question, what is a test? And that's basically up to you. You can put everything into one test. You can write many tests for one application. You have the entire freedom. But in the end, for Checkmk, what generates a status, generates a service is a test. So if you decide if you want a lot of statuses, a lot of services, then for each service you will have to pay in the end, because each service will be licensed and each service is created via a test. Correct. So it's basically up to you. And favorite question, the synthetic recorder.
The recorder.
What's your opinion on the recorder?
Don't use this. The main problem with recording a test is that you get a monolithic piece of code, which includes the test logic, so what should be tested, and it includes the data, for example, logins or something, or articles, and the implementation. And it's a complete bad idea to mix these 3 things together. Code like this is not maintainable, it's not readable. You're running into the same trap as if you would write it in pure Python or something.
So Linux support will come probably in 2.4. What do you think?
Yes.
Then are there any example configurations that can be tested against? So that we simplify somehow the first steps.
Yep. This is an important point, and in the synthetic monitoring documentation, there's a small example which points you to a GitHub repository. So the Checkmk GitHub account has a repository, RobotMK examples or something, and this is the place where I put all these examples into, but also minimal examples and also dummy suites. So suites which do nothing but generate performance data. All these things can be found here. Yeah.
Okay, I mean, you kind of answered it already, but let's go repeat it again. For the tests running on Windows, do we need basically a full-blown Windows task manager or Windows manager, or do we need a complete GUI? What do we need to be able to run tests on Windows?
It depends on which kind of tests. So if you want to run web-based tests, it's possible to run them completely in the system context. Then you do not see any window. And in that case, you can have the session locked. An unlocked session is only needed if you want to test an application which in fact needs a desktop because it has to show some window. In that case, you need this unlocked session.
Okay. Fortunately, you built this already, so it's an easy answer. Is it possible to remap the RobotMK checks to another host, for example, via piggyback?
Yeah, it's included. Yeah.
There was an option in the bakery at the bottom. Okay, and I think this also goes with Linux again. So if you want to run robots on premises in a on-premises cloud, let's take OpenShift, yeah. And in the end, that it makes sense. Like this is only possible when we have Linux support, because then for headless web tests, for example, you can just execute them there.
Right. Yeah.
So, is the RobotMK scheduler always running?
Or can it be not needed? Okay, it depends on the conditions in the bakery rule. So it's a bad idea to have no condition and to deploy the scheduler on all the hosts. Just set a condition which matches the host where you want to deploy this configuration to, and you will have the scheduler running on this machine. Yeah.
And just matching, is the scheduler running asynchronous from Checkmk agent, for example?
Asynchronous.
Or independent, or
so the scheduler is started by the Checkmk agent. This is a special concept called extension, and the Checkmk agent always watches the scheduler, and if you would kill the scheduler, it would be restarted again. And if you stop the Checkmk agent, the scheduler also stops. I do not know if this answers the question, but
yeah, he's nodding. And the last question, yeah. Can we run the scheduler also for other plugins and stuff? And I can answer it. I just had to approve the question from Daniel. That's why I was laughing. But regarding your question, Andre, the scheduler, we intended it really just for RobotMK in the beginning. And I think there were no plans ever to extend it to something else. And I don't even know if this makes sense in the context how it was written. But we don't have plans so far to do so. I mean, you probably have to ask one of the developers there. You can ask Jörg, for example. But I think we didn't plan it. And then, when does finally Linux support come? Soon, of course. Yeah. I mean, we have to do it for 2.4 because we also need it ourselves for our Checkmk cloud. Yeah. Okay. Any other questions? Also from stage is obviously possible, but can't see anything. Then I think we're done. Thank you, Simon.